In this section, we will explore the common popular libraries and frameworks available for programming with large language model applications. We will skim through their key concepts and in comparison of which one to use to effectively program AI-powered applications. Large language models, whether it is local or cloud, using like Mistral, Commander, Gemini Pro, Llama 3, Claude 3, and GPT-4, those all are foundational AI models that perform core tasks such as natural language understanding and generation for us. Then, based on these models, API hostings and management platforms are available. These include OpenAI, Anthropic, Vertex AI, Azure, and Hugging Face. Or if you want to run locally, you have seen there are things like Ollama. These services provide the infrastructures to host and manage large language models, ensuring scalability and the reliability to build the application on top of them. You can generally categorize them into like pay-as-you-go inference public service, or enterprise ML inference hosting service, or public cloud hosting with self-managed model inference service, or you can run locally. Using these inference services, you can build applications directly calling the APIs, or use the components and agents libraries such as Llama Index, LangChain, Semantic Kernel, and Haystack, etc. These are commonly known and popular frameworks to build AI systems efficiently. These libraries offer reusable components and tools, allowing developers to integrate and streamline various elements of their products. They enable the creation of sophisticated AI functionalities by providing pre-built solutions for common tasks. This layer is crucial, providing varieties of reusable components for you to compose a complex combination of your application requirements in a short time. On top of them, there are flows and agent frameworks like LangGraph, CrewAI, AutoGen, and Cognitor. They provide simpler yet opinionated framework to compose the logical flow and task orchestration, allowing more complex and dynamic interactions by using these frameworks. Instead of manually connecting different large language models and managing data retrieval, you can automate these tasks, allowing yourself to focus on the bigger picture than doing commonly needed integrations. There are also low-code tools and app builders and front-end frameworks such as Flowise AI, LangFlow, and Copilot Kits. They simplify development by providing user-friendly interfaces and pre-built components. Faster application creation with less coding. So, these frameworks and libraries are important for reducing complexity and enhancing development efficiency with reusable and integrable solutions. Once you start programming with large language model, you will start with one of them. We will continue looking overview of each of them and compare. LangChain is one of the first open source frameworks for programming with large language model, and it evolved pretty fast and diverged into higher level components and extended frameworks like LangGraph and LangServe. On side note, LangFlow is not from LangChain. LangChain is designed around the concept of chaining the language processing components. Previously, I find it quite a mess to code using LangChain, but over the months, they organized the components well. With version 0.2, I find it easier to use the abstract components while getting some common problems abstracted with LangChain core. For example, asynchronous support at core is quite useful as your code does not have to wait the large language model response before going next step. And the fallback has retry mechanism in calling to large language model, as the API communication to inference server is not smooth all the time. So this core provides something called runnable interface. If you programmed Java before, it is such similar abstract interface for any of your common classes. Runnable interface by LangChain provides sync, async, batch, and the streaming support for any components above. So this made all components can be composed and linked together to build chains. At the topmost level, when you designed an application with LangChain, you would start thinking from the perspective of linking the components in sequential or parallel together, or think in terms of agents given with tool or set of tools called toolkit, reasoning which tool to use to answer to user. And you will also end up defining various retrieval methods of when to retrieve what information from where, etc. The learning curve with LangChain is that it takes some time to get familiar with the library components, names, and constructs, while you're also struggling with how to design your application with large language model in the beginning. Another one of the earliest frameworks and quickly becoming a company is Llama Index. The key concept of the Llama Index framework is its focus on retrieval augmented generation. The RAG process is defined as a pipeline or sequence of stages. Its libraries are designed along these steps of loading, indexing, storing, querying, and evaluating. Loading stage involves fetching data from various sources, converting them into constructs called nodes and documents. For example, getting data from a database, processing and converting them into structured nodes. Then the data is indexed into a format that the large language model can efficiently query. For example, it is like creating vector embeddings for documents to facilitate fast searches. We have not covered about vector databases and embedding yet. I will cover them in additional concepts section. Then the index data and the metadata are stored to avoid redundant indexing. The index data needs to be quickly retrieved and later use it without reprocessing again and again. At the querying stage, user queries interacts with the indexed data. For example, when the user asks for something, we use retrievers to fetch the most relevant data and synthesizing responses using the large language model. Llama Index has a mechanism to evaluate the effectiveness of the queries and responses, such as comparing response accuracy and speed to other strategy. There are also high-level constructs in combination of these processes tailored for data-backed large language model applications, making our lives easier to build advanced functionality, such as query engines are end-to-end pipelines that allows users to pose questions about their data and retrieve relevant answer. They automate the entire process of querying, retrieving, and synthesizing responses. For example, a system that lets users ask questions about a large dataset and get precise answers quickly. And another one, the chat engines, also are the pipelines enabling conversational interactions with the data. User can engage in a dialogue with the systems, asking follow-up questions and receiving contextually relevant responses. Imagine building a chatbot that helps users navigate through the customer support database by understanding and responding to their queries conversationally. Or maybe the agent. These are automated decision makers powered by large language models. These are capable of interacting with external tools and systems. So they all utilize the Llama Index framework to make decisions based on the data. So you see, Llama Index supports the core techniques we discussed earlier, such as RAG, and going towards the directions of agentic pattern as well. Llama Index is much simpler and easy to start with compared to LangChain. Llama Index provides a variety of connectors for integrating with varieties of external data sources compared to the others, making it easier to incorporate diverse information into the large language model applications. If your goal is just about data retrieval and answering on top of that, Llama Index will be a faster and simpler option to build and manage in the long run. So the previous two frameworks we discussed are available in both Python and JavaScript, but this library, Haystack, is only for Python, and it is designed around the concept of pipelines. So combining multiple components as building blocks. So when you design system with Haystack, you would think from the perspective of pipelines and linking the input-output of the multiple components doing the various functionalities. Haystack is designed with simplicity in mind, making it easier to learn and use compared to LangChain, which has steeper learning curve. This is good for smaller teams of projects with the tight deadlines. The provided components are optimized for search-related tasks, such as document retrieval, question and answering, and semantic searches. If your application heavily relies on these features, this is more suitable choice. It also allows to easily customize and combine different components, such as retriever or readers or generators, to create the pipelines and also build your own integrations and the predefined interfaces, similar to Llama Index as well, but with more flexibility in components. Semantic Kernel is an open source framework from Microsoft. It came out around the time similar to LangChain and Llama Index and quickly evolving. As the name implies, it acts as a kernel and operating systems, managing large language model services and plugin to create intelligent solutions. At its core, the semantic kernel consists of a few key components. One of them is connectors. Connectors handle the interaction between the kernel and external large language model services like OpenAI or Azure. The kernel itself orchestrates the flow of data and operations between the different components. Plugins or scales are modular functionalities units that can be easily integrated into the kernel to extend its capabilities. A plugin could be a semantic function, basically a prompt to large language model through connectors and get a response, or a plugin could also be a native function that can run any arbitrary native program code. This can be like interacting with file I/O or search or call external API, etc. Semantic kernel has some goodies features like planner. A planner is a function that automatically generates a plan to accomplish the user's request by combining and orchestrating the available plugins. You could have orchestrated all your defined plugins yourself, but doing so could be like a lot of if-else statements and could end up calling large language model more often. While plugins provide the atomic capabilities, the planner can compose them into cohesive sequences and data flows to serve the user's intent. Planners should be used when you want to make the applications do dynamically handle complex, multi-step scenario without having to manually code for each specific case. Semantic kernel also supports agents as high-level composition elements, which are comprised of plugins, planners, and personas. Plugin provides specific skills for tool use. Planners offer guidance on how to combine those skills, and personas add a layer of personality to the agent's interaction. With these modular approaches, developers can create highly customized AI agents tailored to their specific use case. Being originated from Microsoft, this supports C# as alternative to Python. Given our understanding on how each of the frameworks allow us to create the intelligent solutions, here is an example scenario that can be programmed in any of these frameworks. This is the example chat bot for the gardening. Something is that the gardening articles are available in a folder and they can be used to answer the questions from the user. So in the case of Llama index, it is as simple as creating the documents from the directory and build index on top of that and query that index using the query engine. We can use the LangChain in the similar patterns, whereas it used the directory loader to create the documents and build the vector store and use the retrievers to answer the questions. LangChain provides flexible component selection to create more complex structures. Haystack, on the other hand, creates pipelines of retrievers and generators on top of the document store. Semantic kernel connects with text completion service, create the plugins and gardening skill, and use it to answer the questions. So these are the code comparisons for you to see how they all can be used for a simple chatbot scenario with the data. Depending on your requirements and the simplicity or flexibility of the programming work, you would like to choose one of these libraries. Any one of them will help save time to quickly develop your application. The primary difference is in the conceptual constructs that you like and comfortable with, and how many reusable components are available in each of them. So far, we have looked at the overview of each components or agent libraries. Next, we will look at the overview of higher level frameworks with OpenAI native abstractions in creating AI solutions, such as LangGraph, CrewAI, and AutoGen. As the name implies, this framework is about creating a crew of agents, each of them assigned with specific tasks and given tools to follow a defined process in solving problems. Given your instructions, the crew will execute own assigned tasks using the given tools and collaborate between each other through the process, without having to think about data store, retrieval strategy, or connection to large language model. The framework covers the complex combination of components, but offers the option to think in real-world alike collaborative problem-solving team. Think of your software as a crew of agents and their special assigned tasks and tools. So do look at the code example to see how simple it is to define a program using CrewAI. LangGraph, also as the name implies, it is based on designing the solution as a workflow in the form of graph. This is somewhat similar to Haystacks directed graph pipelines, but with strict definitions and abstraction in the graph components. The workflow composed of states, nodes, and edges. States keep the whole context, whereas nodes are function logic representing an agent. And edges are gated communication between nodes, which determines the sequence to call the nodes. This allows us to design a complex combination of logical execution sequence between the nodes. The flexibility comes with complexity. How complex one can make in the nodes is up to the developer. But the key frame is in defining states, nodes, and edges. So it is quite scalable in development to split the work between engineers or the teams in defining their respective nodes and combine them into graph later. I'll not go through the example for the sake of time, but do look at the code in comparison to the Crew AI code as well. AutoGen is now owned by Microsoft. Its approach is slightly different. It uses the concept of conversable agents collaborating to complete a task. Sounds familiar? So a slight difference with Crew AI is that user can be part of conversation group in collaboration. So you can imagine like a regular chat room with multiple bots and multiple users interacting together to get things done, or a team of autonomous agents collaborating themselves and from time to time communicate with user for reporting and getting approval. So there are various patterns of conversation supported by this framework. Do look at the group chat example in the given tutorials. Here is a comparative summary of how these frameworks are different to one another. All of them has abstracted the complexity of interaction with large language model and its underlying common libraries. And they give us logical structures to design relatable and scalable AI applications. Your choice would depend on whether your project prioritizes clear role-based tasks or require sophisticated control flow and scalability or customized conversational agents with the human feedbacks. To further extend the comparison, let's imagine a problem scenario where we need to design a system for multiple smart agents within a business team to collaborate on reviewing, advising, supporting, and criticizing a given business proposal. Each agent should assess specific data and evidence based on their role to provide a comprehensive evaluation of the proposal. We can approach designing the solution using different frameworks, such as Crew AI, LangGraph, or AutoGen. The key difference lies in thinking in terms of each framework's core concept and defining the solution using their provided logical components and structure. With Crew AI, we would define agent roles like financial analyst, market analyst, legal advisor, etc., and then assign them with the tasks to each role, such as financial analysis, market analysis, or legal review, etc. Then select the tools and data sources for each agent to perform their tasks effectively. Design a workflow, outlining the collaboration process among them. In contrast, using LangGraph, we would define states like initial review, financial review, or market review, or legal review. Create nodes for tasks such as collect initial data, perform financial analysis, perform market analysis, etc. Then we establish the edges to control the flow of data and transition between the states. We can map out the workflow as graph, defining states transition. AutoGen take a different approach by defining high-level agents like assistant agent, user browsing agents, and specific specialist agents like financial analyst agents. We would configure agents' interaction, integrate with the tools, and set up automated conversations to enable the agents to converse, share insights, and collaborate on the proposal evaluations. So each approach has its own strength, and the choice depends on factors like problems complexities and the team's familiarity with the framework, and of course the desired level of abstraction you like to go.